Hi, everyone. So in this lesson, we're going to talk about the basic chemistry that will help you when we start talking about biochemistry. So atoms are the building blocks. Everything is made up of elements. Elements are just types of atoms, essentially. And atoms are made up of three subatomic particles. And those are protons, neutrons, and electrons. Protons are positively charged, and neutrons have no charge. Neutron or neutral helps me remember that they have no charge. Both protons and neutrons are found in the nucleus. Electrons are not found in the nucleus. They orbit the nucleus and are negatively charged. This is the CK12 textbook periodic table. So if you're looking for this one again, you can find it in the CK12 textbook. On the left, you can see that the atomic number of an element is in the upper left corner, and that is the number of protons. So hydrogen has 1, helium has 2, lithium 3, and so on. Elements are pure, and they are arranged by their atomic number. The atomic mass is underneath the letters there, and it is the protons plus the neutrons. They make up the mass. So that's it written out there. So there's the nucleus, which is the mass of the atom, and then there's the electron cloud, which is composed of layers, and that's of layers of the electrons. The first shell, there are 2 electrons. The second shell, there are 8, and the third, there are 18. So let's look at an example. So carbon has 6 electrons. How do I know that? So the atomic number of carbon is 6, and that's the number of protons, right? So protons actually equal the number of electrons. So there are 6 electrons. And most of them, when you look at the atomic number on the periodic table, that's what tells you this is the number of protons and the number of electrons. And as you can see, the first shell has 2 electrons and it's filled. And then the second shell only has 4. And so it has 4 outer shell electrons. And we'll talk about specifically about valence in a little bit. A couple other terms that I think are important for you to know are molecule, which is atoms bonded together. We'll talk a lot about molecules when we start biochemistry. An ion is a charged particle which has gained or lost electrons. So similar to what I talked about before, carbon, if you add or take away electrons, you will change its charge. If it loses an electron, it would be positive. If it gains one, it would be more negative. An isotope is the same element, but different number of neutrons. So it changes the atomic mass. Iso means same, so that maybe will help you remember that. And something also to note is a half-life is the amount of time it takes for half of a sample of radioisotopes to decay. So let's talk about octet rule and valence a little bit more. So the octet rule is essentially saying that an atom must have 8 electrons or a full outer shell to be stable. Atoms that don't have 8 or a full outer shell are very reactive. Atomic valence is the number of electrons to get to an octet. This tells us the number of bonds that an atom will most likely try to make. So let's look back at carbon really fast. So if they have 4 electrons in its outer shell, that would mean that 4 is its valence because it's 4 until 8. So it will probably make 4 bonds, most likely. And as you can see, oxygen's valence is 2. So it makes 2 bonds with hydrogen to make water. Hydrogen, on the other hand, only has 1 electron. So it's trying to fill that shell, and that first shell only has 2. So when it's bonded with oxygen here on both sides, both of these hydrogens are satisfied because they only need 2 in their shell to be stable. Okay, let's talk about some water properties. So an important property to note about water is polarity. It has slightly positive or negative ends is what polarity means. And this allows it to make hydrogen bonds, which are weaker bonds, but they're attractive forces. So this is what creates surface tension because of the cohesion, because they're weakly bonding to the hydrogen around it, to the other water molecules. So that's why you can push through the water really easily, but it's also why bugs will be able to walk on top of the water because of that surface tension. Another thing that's important about it is it makes them it makes them tend to want to be near each other. So capillary action is actually when water goes up into a plant and other water molecules follow it because they want to be close to each other. So they follow each other. It also gives it the property of stabilizing temperature. So it keeps things at certain temperatures. And it expands when it freezes because it wants to be close to each other, but they slow down. The molecules slow down, so they want to still be close to each other. So it creates those crystallizing structures. The last thing I want to talk about is solutions and pH. So a solution is one thing that's evenly distributed. So like a smoothie, you blend it all together, and it would be almost impossible. It would be impossible to separate because it's one thing now. It is evenly distributed and it is one thing. While a mixture is like a salad that you mix all together, that you can take the pieces out. And water dissociation causes pH differences. So when it dissociates, it's H plus ions and OH minus ions. So H plus is acidic and OH minus is basic. And when there's more of either, you get pH differences. So 0 to 6.99999 is acidic, and 8 to 14 is basic. So 7 is neutral. 7 is right in the middle and neutral, and that's usually where water is.